Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions: the mystery of the Yellowstone Supervolcano. What happens when the world's largest bomb goes off? Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction. Not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. Beneath Yellowstone National Park lies the largest supervolcano in North America, a magma chamber 90 kilometers long, 40 kilometers wide, and 15 kilometers deep. When it last erupted 640,000 years ago, it deposited ash across half of North America and punched a caldera into the landscape so large it took geologists decades to recognize it as volcanic in origin. Before that eruption, there were two others: one, 3 million years ago, and two, 1 million years ago. Three supereruptions, separated by roughly 700,000 years each. We are currently 640,000 years past the last one. The mathematics are obvious, and the USGS is quick to clarify that Yellowstone does not erupt on a clockwork schedule, but the question of what happens if, and when it does, is not alarmism. It is one of the most consequential risk assessments in geology. The last Yellowstone supereruption deposited ash as far as the Gulf of Mexico. Climate models suggest a future supereruption would inject enough sulphur dioxide into the stratosphere to drop global temperatures by several degrees Celsius for years. A volcanic winter that would devastate agriculture across the Northern Hemisphere. The USGS monitors the system continuously and publishes weekly updates. Their current assessment is that nothing unusual is happening, but they also acknowledge that no human has ever observed a supervolcano in the years before it erupts. We do not have a baseline. What would Yellowstone actually look like if it were waking up, and would we recognize it in time? This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the landscape of modern documented mysteries, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. The 20th and 21st centuries were supposed to be the age of answers. Science had decoded DNA, split the atom, put humans on the moon, and mapped the genome. By the logic of accelerating discovery, every mystery should be converging toward explanation. And yet the ledger of genuinely unexplained phenomena, events witnessed by credible observers, investigated by serious researchers, and still lacking a satisfying account, has not shrunk. If anything, it has grown. Part of this is a failure of classification. Phenomena that do not fit established categories tend to be dismissed rather than investigated, filed under anecdotal or mass hysteria, and removed from serious consideration. This is not always wrong. Genuine hoaxes and misperceptions account for a large portion of anomalous reports. But the dismissal is sometimes premature, and the cost is real. Cases that might have yielded genuine insight are closed before they are fully examined. Witnesses are discredited. Evidence is lost. The question is never properly asked. The cases that endure, that survive rigorous scrutiny, and still refuse to yield to conventional explanation, are a small but significant set. They share certain characteristics: multiple independent witnesses, physical evidence consistent with witness testimony, and a complete absence of any plausible prosaic explanation that accounts for all the data. These are not ghost stories. They are open problems in empirical science, waiting for someone with the right tools and the intellectual courage to take them seriously. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades. And patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter. The core evidence surrounding the Yellowstone Supervolcano. What happens when the world's largest bomb goes off is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. The Yellowstone caldera was formed by the most recent supereruption 640,000 years ago, which produced the Lava Creek Tuff, a deposit of volcanic material covering hundreds of thousands of square kilometers. The caldera itself measures approximately 72 by 55 kilometers. It was not recognized as a volcanic caldera until the 1960s because it is so large that its rim is not visible from ground level within it. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered seismic tomography conducted by the University of Utah in 2015 confirmed the magma chamber dimensions, approximately 90 kilometers long, 40 kilometers wide, and up to 15 kilometers deep. A second, deeper magma reservoir was identified in 2022 beneath the shallower chamber. The combined magma system is one of the largest known on Earth and drives Yellowstone's extraordinary hydrothermal activity. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine. Yellowstone contains approximately 3,000 geysers and hot springs, more than half of the world's total. Old Faithful erupts approximately every 90 minutes. The park's hydrothermal system releases an estimated 1,600 to 3,000 tons of carbon dioxide daily through fumaroles, hot springs, and soil degassing, a direct indicator of the heat flux from the underlying magma system. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation, but the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, the USGS Yellowstone Volcano Observatory monitors the system continuously using seismometers, GPS ground deformation sensors, gas detectors, and satellite interferometry. Ground uplift and subsidence cycles have been measured since the 1920s. The caldera floor rose approximately 1 meter between 1923 and 1984, then subsided 20 centimeters between 1984 and 1995. This breathing cycle reflects changes in hydrothermal fluid pressure, not necessarily magma movement. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of the USGS estimates the annual probability of a Yellowstone supereruption at approximately 0.00014%, roughly 1 in 730,000 per year. This is based on the 3 known supereruption intervals and does not imply the volcano is overdue. Volcanic systems do not erupt on regular schedules. The intervals between the three Yellowstone supereruptions were not identical: 800,000 years and then 660,000 years. And the current interval of 640,000 years is shorter than both previous gaps. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding: a Yellowstone supereruption would be categorically different in scale from all historical volcanic events. Ash fall from the last supereruption reached the Gulf of Mexico and the Pacific coast. Climate modeling suggests a supereruption would inject enough sulphur dioxide into the stratosphere to cause a volcanic winter lasting several years, with global temperature drops of several degrees Celsius, potentially catastrophic for agriculture across the Northern Hemisphere. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations, and in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain the Yellowstone supervolcano. What happens when the world's largest bomb goes off? This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that the USGS and mainstream volcanology maintain that a Yellowstone supereruption is not imminent, and current monitoring shows no unusual precursors. Current activity is within normal parameters for a geologically active hotspot system. Any future eruption would likely be preceded by measurable precursors: ground deformation, seismicity, gas output changes, detectable years in advance. The main caveat is that our baseline for supereruption precursors is essentially non-existent, because no human has ever observed one. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that some volcanologists argue that the Yellowstone hotspot has been decreasing in intensity over its lifespan as it moves relative to the North American plate, and that the most likely outcome of any near future volcanic activity is a rhyolitic lava flow rather than an explosive supereruption. This view holds that the catastrophic supereruption scenario, while possible, is less probable than less dramatic volcanic events. Critics note that all three previous Yellowstone eruptions were supereruptions, not effusive flows. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that a third perspective focuses on the more probable near-term hazard: hydrothermal explosions rather than magmatic eruptions. In 1989, a hydrothermal explosion at Pork Chop Geyser created a crater 5 meters across. Bachelor's Meadow crater, formed roughly 13,800 years ago, is 2.5 kilometers across evidence that hydrothermal explosions can be very large. This category of event is more frequent and would cause severe localized damage without global consequences. What is striking about this debate is not merely that experts disagree. That is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers working from the same body of evidence reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding the Yellowstone Supervolcano, what happens when the world's largest bomb goes off, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes the 2015 seismic tomography study published in Science by Jamie Farrell and colleagues at the University of Utah provided the first clear three-dimensional image of the Yellowstone magma system, confirming the chamber dimensions and revealing that approximately 5 to 15% of the chamber volume is currently molten. The remainder is crystallized mush. A fully molten magma chamber of that size would represent an eruption-ready system. The current partially molten state is consistent with a dormant but active system. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented the 2014 earthquake swarm 300 earthquakes over 3 months was the largest seismic swarm at Yellowstone since 1985. It generated significant media alarm, but USGS analysis confirmed it was consistent with normal hydrothermal and tectonic activity rather than magma intrusion. The swarm actually provided useful data. The seismicity patterns were inconsistent with the kind of magma movement that precedes eruptions. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed Yellowstone's eruptive history is recorded in ash deposits across North America. Geochemical fingerprinting of ash in sediment cores from as far away as the Gulf of Mexico and the Pacific Northwest has allowed precise dating and volume estimation of all 3 supereruptions. The Lava Creek Tuff from the 640,000-year eruption represents roughly 1,000 cubic kilometers of material, approximately 500 times the volume of the 1980 Mount St. Helens eruption. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding the Yellowstone Supervolcano. What happens when the world's largest bomb goes off? Now, we need to ask the question that is sometimes overlooked. in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. The USGS Yellowstone Volcano Observatory publishes weekly status updates and has maintained continuous monitoring since the 1970s. The 2022 seismic study identified an additional deeper magma reservoir, refining the picture of the system's total magma volume. Current monitoring shows no precursors indicating elevated eruption risk. The more probable near-term volcanic hazard at Yellowstone is a hydrothermal explosion, not a supereruption. Monitoring technology, satellite radar interferometry, continuous GPS, real-time seismic networks has improved dramatically and would provide substantial warning of any change in system state. Yellowstone remains one of the best monitored volcanic systems on Earth. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of the Yellowstone Supervolcano. What happens when the world's largest bomb goes off from the historical record? Through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Yellowstone ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.